When we talk about friction in these two types of simple machines, we know that any time two parts of a machine come into contact, friction is created. And friction is actually created in the form of thermal energy. It's heat. You see that when you rub your hands together. Okay, the imperfections in your skin on both sides, okay, create quite a bit of friction, and that gets transferred from the muscular energy of you moving your arms into a thermal energy, heat. Okay? So friction opposes forward motion, it's a force, but friction is also when parts in a machine come into contact with one another. And we can do a few small things to help us lessen friction. Okay, we're not too worried about the friction in a lever. The friction in a lever is pretty non-existent because the only place that there's contact is at the fulcrum and the bar, and where the load actually comes into contact and where the effort comes into contact. Not a lot of friction. Where friction does start to play a bigger role is in a pulley system. Okay? In a pulley system, we end up having our wheel, right? And then we have, and I'm actually going to draw it out here, we usually have our axle. Now, we tend to have our rope that goes through our pulley or around our pulley like so, right? Our load is down here and our effort is over here. So we're pulling down and it's causing the load to go up. This is a single fixed pulley. It doesn't really matter what kind of pulley, because this happens in any wheel and axle. Okay, in any type of pulley, whether it's a movable pulley, a single fixed pulley, or a multiple pulley system. Every pulley is experiencing friction. And that friction is going to be where the actual rope comes into contact with the wheel. They rub against one another. And where the axle comes into contact with the actual wheel. That creates friction. And the more friction you create, the more effort you're going to have to put in to overcome that friction. For the most part, the friction is minimal. Okay, but if we're trying to get as efficient a machine as possible, there are a few things that we can do to minimize friction, which means to lower friction. Okay? One of the first things we can do to lower friction is we can actually use as smooth a rope as possible. Okay, something that is synthetically smooth. Compare a twine rope or a hemp rope or something like that, something woven, to something plastic. The plastic's a lot smoother. Okay, it's made to be smoother. So using smoother materials for a rope can lessen the friction from here to here on this rope when the rope comes into contact with the pulley. Okay, that's one way of lowering the overall friction in the system. Another thing we can actually do to lessen the friction both on the rope and in the actual wheel and axle where they come into contact is by lubricating them. Okay, and using a lubricant, lubricants are often found in the form of grease or oils, and they basically coat both objects and make them smoother. So the smoother something is, the less friction it has. So using a lubricant will help lower the actual amount of friction, because that coat of oil or grease over the surface will actually make it smoother. And you know that by, if you've got oil or something on your hands and you try to open a doorknob or you try to open a jar, it doesn't work very well. Your hands slide around the jar. Okay, you can't get a good grip. That's because there's very little friction there. And the third thing we can do, we actually talked about this and we saw examples of it, is the incorporation of ball bearings into the actual wheel and axle section of the pulley. So right here, because we see that that line of purple there goes all the way around. And that means that the entire wheel is coming into contact with the entire axle. There's a lot of surface-to-surface rubbing there, a lot of friction. So using ball bearings lowers that. So the use of ball bearings are small, tiny little steel spheres. Okay, they're three-dimensional circles. And what they do is they're placed in between the actual wheel, okay, so this is the wheel and this is the axle. And they're placed in between the wheel and the axle. And what they actually do is they minimize the amount of friction that we see. So we only see friction where the actual ball is touching both the wheel and the axle rod, okay? As opposed to the total friction that we saw or that we see in a pulley with no ball bearings. So ball bearings will help minimize the surface-to-surface contact, so they help lower friction.